All right, do not be scared of this question. I know it looks crazy, but there's just one thing really we need to memorize here. So that it's clear from the answer choices, which we should definitely look at while we're reading the question, before we read the question, that we're thinking about a formula for exponential equations, right? So the general formula that we use is what I call the open formula. And it has a little bit of a change for these particular situations, right? So it's normally used to calculate percentages. The way I normally describe it is like this. The original, that's the O, is times the change in percentage to the t, which is usually time, is equal to some new value, right? So that's kind of what's happening here. So here's how we're going to use this formula to start the question, and then we're going to change it slightly. A ball is dropped from an initial height of 22 feet. Right away, we're given our original value. So what does that mean? That means 22 has got to go right here out front. So that gets rid of C and D without really any effort at all. Okay, you have to memorize this and how exponentials work. Another way to understand this idea is this is kind of like our y-intercept. It's what happens when x, or in this case n, is equal to 0. Most of the time, for any story that they give us in the SAT, exponential or otherwise, we're going to get a y-intercept. We're going to get some initial value. So you have to be able to think about it in that way and apply it to either the formula for that particular equation, or just think of it as a point that you plug in. So if you wanted to do plug points into equations here, the point we're plugging in would be 0, 22. And again, that would only work in choices A and B, because anything raised to the 0 power is going to be 1. So choices C and D are really just 85 times 1, but 85 times 1 is not equal to 22. Now, continuing, a ball is dropped from an initial height of 22 feet and bounces off the ground repeatedly. The function h estimates that the maximum height reached after each time the ball hits the ground is 85% of the maximum height reached after the previous time the ball hits the ground. Okay, this is not as crazy as it sounds. Which equation defines h, where h of n is the estimated maximum height of the ball after it hits the ground n times, and n is a whole number greater than 1 and less than 10? Most of this story doesn't matter. Let's just focus on the 85. Basically, at this point, you should just be like, well, there's A and B, and only B has 85. Boom, done. That's it. That's the answer. Now, the reason this is slightly different from the formula that I gave you at the beginning is they're presenting the percentage not as a change in percentage. It's not like it's saying it's 85% less than the previous height. It's 85% of the previous height. So the change that we should make to our formula for that reason is going to be this. That instead of the percentage being this 1 plus or minus, which represents percent greater than, percent decrease, a change in percentage, it's just a plain old percent, 85% of the previous height. So we're just going to put 0.85 in as our decimal version of the percentage into the equation. So that's why it's a little different from the typical way that exponentials appear on the SAT. But because of the answer choices that they provided us, it's fairly obvious, I think, that B is going to be the only one that makes sense. And this is a great example of just like why you cannot give up too easily on word problems. Most of the time, we can use the fact that there's a limited number of answer choices to kind of process of elimination our way to the answer. You don't need to understand the story completely to be able to get the right answer confidently. So don't quit on those. There's some stuff to memorize, but a lot of it is just kind of comparing the answer choices and breaking your process down into smaller decisions. Is the 22 out front, or is the 85 out front? Make that decision first, then worry about the other piece, and everything will fall into place.